Scientists just found something in deep space that makes every horror movie look comforting. Not terrifying, comforting. And the worst part? They're not telling you the full story. So let me do what they won't. Because what I'm about to show you will change the way you see everything. The stars above you, the world beneath you, even your own existence. We grow up thinking the universe is beautiful, a peaceful ocean of glittering stars and colorful nebulas. But that's the biggest lie in science. That's the postcard version, the brochure. When you peel back the cover, when you stare into what's really out there, you realize something terrifying. We are living in a cosmic minefield. A place so violent, so unpredictable, so hostile, that the fact you're breathing right now is nothing short of a cosmic miracle. And here's what nobody tells you. Scientists know this. Space agencies know this. They've known it for years. But why start a global panic when most of these threats travel faster than warning systems and hit harder than anything we could ever prepare for? So they stay quiet, and you stay comfortable. But comfort is the enemy of understanding. And you deserve to know the truth, because right now, at this exact moment, there are things moving through space that could erase us instantly. No sound, no warning, no chance to run. So let me take you into the real universe, the one behind the documentaries, behind the pretty animations and soothing narrators. The universe that's indifferent to us. The universe that's dangerous. The universe that, statistically, should have killed us a long time ago. And by the time we're done, you will never look at the night sky the same way again. Everything you learned in school, in movies, on the news, has been carefully edited to hide what war really does to people. Today, I'm going to show you what they never teach you, the parts of history books they delete, the stories veterans whisper only in the dark, the truth so uncomfortable, most people pretend it doesn't exist.
Let's start with something that happened in 2008. Scientists were monitoring a star system about 7,500 light-years away. Nothing special, just routine observations. And then, without any warning, they detected something that made every astronomer who saw the data go completely silent. A gamma-ray burst. But not just any gamma-ray burst. This one was pointed almost directly at Earth. Now, before I continue, you need to understand what a gamma-ray burst actually is. Because when I say burst, you might be thinking of something small, like a bubble popping. But that's not even close. A gamma-ray burst is the most powerful explosion that can occur in the universe, period. Nothing else even comes close. When a massive star dies, sometimes it doesn't just explode. Sometimes it collapses into a black hole so violently that it shoots out beams of pure energy from its poles. These beams are so concentrated, so absurdly powerful, that they can cross the entire observable universe and still be deadly. How deadly? Let me put it this way. If a gamma-ray burst happened in our galaxy, anywhere within a few thousand light-years of Earth, and one of those beams hit us, it would be over in seconds. Not minutes, not hours, seconds. The beam would hit our atmosphere, traveling at the speed of light. We wouldn't see it coming. There'd be no warning, no time to prepare, no time to say goodbye. One second, you're living your life, and the next second, the sky lights up brighter than the sun. The gamma rays would rip through our atmosphere and destroy the ozone layer instantly, just gone. And without the ozone layer, we're completely exposed to solar radiation. But it gets worse. The gamma rays themselves would penetrate deep into the atmosphere, creating nitrogen oxides that would cause acid rain, the kind of acid rain that would destroy crops worldwide. The food chain would collapse within weeks. And even if you somehow survived the initial blast by being underground or something, you'd starve. Or you'd die from the radiation poisoning, or you'd die from the chaos that would follow when society collapsed. So back to 2008. This gamma ray burst they detected, the one that was pointed at Earth. It went off 7,500 years ago, and the beam reached us in 2008. Think about that for a second. That star died when humans were just figuring out agriculture, and the death beam traveled through space for 75 centuries before finally reaching Earth. Luckily, it was far enough away that it didn't kill us, but it was still one of the brightest things we've ever detected in space. If it had been closer, say 1,000 light years instead of 7,500, you wouldn't be watching this video. Nobody would be watching anything, because we'd all be dead. And here's the part that should terrify you. There are stars in our galaxy right now that could go gamma ray burst at any moment, and we have no way of knowing when, or more importantly, which direction their poles are pointing. There's a star called WR104, about 8,000 light years away. It's what we call a Wolf-Rayet star. These are massive stars near the end of their lives, and when they die, they often produce gamma ray bursts. For years, scientists have been trying to figure out if this star's rotational axis is pointed at Earth. Some studies say yes, some say no, some say maybe. The truth is, we don't know. And even if we did know, it wouldn't matter, because that star could have already exploded. The light from the explosion and the death beam could already be on its way to us right now, and we won't know until it gets here, 8,000 years after the star actually died. You could be sitting there right now, completely safe, while a gamma ray burst is racing toward Earth at light speed. You'd have no idea, no warning. You'd just be living your normal life, and then one day, the sky would explode. That's the universe we live in. But let's say we get lucky with gamma ray bursts. Let's say none of them hit us. There are still so many other ways the universe is trying to end us. And the next one is something you've probably heard about, but don't really understand the true danger of: asteroids. Everyone knows asteroids killed the dinosaurs. That's common knowledge at this point. A big rock from space hit Earth, caused massive destruction, wiped out most life on the planet. But what most people don't realize is just how many asteroids are still out there, and how little we actually know about them. NASA loves to tell us they've cataloged 90% of the near-Earth asteroids larger than 1 kilometer. And that sounds good, right? 90% is an A in school. But think about what that actually means. That means 10% of the planet-killing asteroids out there are completely unknown to us. We have no idea where they are, when they might hit us, if they're on a collision course right now. And that's just the big ones. There are millions, literally millions of smaller asteroids that we haven't cataloged. Asteroids that are 50 meters, 100 meters, 200 meters across. These wouldn't end all life on Earth, but they would absolutely destroy a major city, level it completely. And we miss these constantly. Let me tell you about Chelyabinsk. February 15th, 2013. A normal Friday morning in Russia, people going to work, kids going to school, normal day. And then, out of nowhere, a fireball streaked across the sky. It was an asteroid, only about 20 meters across, not even close to planet killer size, but it was moving at over 40,000 miles per hour. And when it hit our atmosphere, it exploded with the force of 30 Hiroshima bombs. 30! The shock wave shattered windows across 6 different cities. Over 1,500 people were injured, most from flying glass. And here's the kicker. Nobody saw it coming. Not NASA, not any space agency, not any telescope. We had zero warning. Zero. You know why? Because it came from the direction of the sun. Our telescopes can't look directly at the sun. We're blind to anything approaching from that direction. And this asteroid just happened to come from the one place in the sky we can't monitor. Pure luck that it wasn't bigger. Pure luck that it exploded over a relatively rural area instead of over Moscow or New York or Tokyo. Pure luck that it wasn't 100 meters instead of 20. Because if it had been, we'd be talking about hundreds of thousands of deaths, maybe millions, and we'd still wouldn't have seen it coming. Now imagine an asteroid 500 meters across, or a kilometer, approaching from the direction of the sun. We wouldn't know until it was too late. And even if we did see it coming from a different direction, what would we do? We tested something recently called the DART mission. We crashed a spacecraft into an asteroid to see if we could change its orbit. And it worked. Kind of. We moved a small asteroid slightly. But that was a controlled test. We had years to prepare, years to plan. If a real threat showed up tomorrow, we'd be scrambling. We don't have asteroid deflection technology just sitting around ready to deploy. We'd have to build it, test it, hope it works, all while an extinction-level rock is hurtling toward us.
The universe is constantly throwing rocks at us. Big ones, small ones, medium ones. We're in a cosmic shooting gallery, and the only reason we're still here is because we keep getting lucky. The gaps between the bullets keep lining up with where we are. But luck runs out eventually. And speaking of things we can't see, let's talk about dark matter. This is where things get really weird, really disturbing, because dark matter makes up about 27% of the universe. Everything you can see, all the stars, all the galaxies, all the planets, all the gas, everything made of atoms, that's only about 5% of the universe. The rest is dark matter and dark energy. And we call it dark not because it's evil or black, but because we literally cannot see it. It doesn't interact with light at all. It's completely invisible. We only know dark matter exists because galaxies are spinning too fast. The visible matter in a galaxy isn't enough to hold it together. The stars are moving so fast that they should fly apart, but they don't. Something else is there, providing extra gravity, keeping everything together. So we call that something dark matter, but we have no idea what it actually is. We've been looking for it for decades. We've built massive detectors underground, trying to catch a dark matter particle passing through. Nothing. It's all around us, passing through us right now, passing through Earth, and we can't detect it. Think about that. Almost a third of the universe is made of something we can't see, can't touch, can't detect, and don't understand. And here's where it gets scary. What if dark matter isn't just passive? What if it can do things? We assume it just sits there, being invisible, providing gravity. But what if it can clump together? What if there are dark matter structures out there? Dark matter clouds, dark matter planets, dark matter stars, all existing in the same space as our universe, but completely invisible to us. Some scientists have theorized about dark matter clouds passing through our solar system. dense regions of dark matter that could gravitationally disrupt planetary orbits. And we'd never see it coming. We wouldn't know it was there until suddenly Earth's orbit started changing, until we started getting pulled closer to the sun or pushed further away, until our perfect, stable, habitable orbit was destroyed by something we can't even detect. And it gets worse. Dark energy. This makes up about 68% of the universe. It's the force causing the universe to expand. And not just expand, but accelerate. The universe is getting bigger faster and faster. And we have absolutely no idea why. We don't know what dark energy is. We don't know where it comes from. We don't know how it works. We just know it's there because we can measure its effects. But here's the nightmare scenario. What if dark energy isn't constant? What if it can change? Right now, dark energy is causing expansion, but it's gradual, slow. But what if it suddenly got stronger? What if there's a phase transition and dark energy suddenly increases in power? Then the expansion of space would become violent, extreme. And there's a theoretical event called the Big Rip. This is where dark energy becomes so strong that it literally tears everything apart. Not just galaxies, not just solar systems, everything. Planets, molecules, atoms, even the particles that make up atoms. Space would be expanding so fast that nothing could hold together. The forces that bind matter would be overwhelmed, and everything would be ripped apart into individual particles. And then those particles would be ripped apart until there's nothing left. When would this happen? Current estimates say at least 22 billion years from now. But those estimates assume dark energy stays constant. What if it doesn't? What if dark energy can spike? What if the Big Rip could happen tomorrow? We wouldn't see it coming. We wouldn't know until space itself started tearing apart, and there'd be nothing we could do. Nowhere to run, nowhere to hide, because space would be ripping apart everywhere simultaneously. So we've got gamma ray bursts, asteroids, dark matter, dark energy, and we're not even done yet. Let's talk about something closer to home, something that keeps astronomers up at night: our own sun. The sun is what makes life on Earth possible. We all know this. It provides heat, light, energy. Without the sun, Earth would be a frozen rock. But the sun is also a massive nuclear reactor. It's fusing hydrogen into helium in its core, releasing enormous amounts of energy. And that energy doesn't always come out smoothly. Sometimes it comes out in bursts, explosions on the surface of the sun, solar flares, coronal mass ejections, billions of tons of charged particles being hurled into space at millions of miles per hour. Most of the time, these explosions miss Earth. Space is big. The sun is throwing matter in all directions. Earth is small. The chances of a direct hit are low, but not zero. And when Earth does get hit, we call it a geomagnetic storm. The charged particles slam into Earth's magnetic field. The interaction creates beautiful auroras near the poles, the northern lights, the southern lights. Pretty, right? But it's not just pretty lights. These storms can cause serious damage. In 1859, there was an event called the Carrington event, the most powerful geomagnetic storm ever recorded. Telegraph systems worldwide failed. Some caught fire. Telegraph operators got shocked by their equipment. And this was in 1859, when our technology was primitive. We barely had electricity. Now imagine the same thing happening today.
Our entire civilization runs on electronics, power grids, internet, satellites, GPS, banking, hospitals, air traffic control, everything.
A Carrington-level event today would be absolutely catastrophic. Power grids would overload and burn out. Transformers would be destroyed. And here's the problem. We don't have spare transformers just sitting around. These things take months to build, maybe years. And if thousands of them get fried simultaneously, we can't replace them fast enough. Which means no power for months, maybe years in certain regions, maybe everywhere. And no power means no water pumps, no sewage treatment, no refrigeration, no hospitals, no communication. Society would collapse. Millions of people would die, not from the storm itself, but from the chaos that follows. And this isn't a distant hypothetical. In July 2012, a solar storm of Carrington-level intensity erupted from the sun, and it missed Earth by 9 days. 9 days! If the sun had belched out that explosion a week and a half earlier, it would have hit us directly. We got lucky. Again. But how many more times can we get lucky? And the sun is becoming more active. We're entering a new solar maximum, the peak of the sun's 11-year activity cycle. More sunspots, more flares, more coronal mass ejections, more chances for a direct hit. And we're not prepared. We haven't hardened our power grids. We don't have backup systems ready to go. We're just hoping it doesn't happen, crossing our fingers and hoping our luck holds. But even if the sun doesn't fry our electronics, there's something even more terrifying lurking in the center of our galaxy. A monster so massive that it defies comprehension. Sagittarius A star, a supermassive black hole with a mass of about 4 million suns. Just sitting there, 26,000 light-years away, slowly devouring everything that gets too close. Black holes are the ultimate predators of the universe. Nothing escapes them. Not matter, not light, not even information, according to some theories. Once you cross the event horizon, you're gone, forever. And supermassive black holes are the worst because they're so massive that you might not even realize you've crossed the point of no return. The tidal forces wouldn't rip you apart immediately. You'd just be falling, accelerating, with no way to stop, no way to escape. And by the time you realized you were doomed, it would be way too late. Eventually, the tidal forces would kick in. Your body would be stretched, longer and longer, thinner and thinner, until you were just a stream of atoms spiraling into the singularity. Scientists call this spaghettification, which sounds funny until you really think about what it means. Now, Sagittarius A star is far away. We're safe from it, probably. But black holes move. They drift through space. And there could be rogue black holes out there, wandering through the galaxy, invisible, silent, until they get close enough to something that they start consuming matter and giving off radiation. A rogue black hole could be heading toward our solar system right now, and we would know until it was basically here, until it started messing with the orbits of the outer planets. And by then, it would be too late. It would distort everything, potentially fling Earth out of the solar system entirely, send us careening into interstellar space, where we'd freeze, where the sun would become just another star in the sky, too far away to provide any heat. And we'd all die, slowly, as the planet cooled, as the atmosphere froze and fell to the ground as snow, as the oceans turned to ice, all because a black hole we couldn't see decided to pass through our neighborhood. And here's something that will really mess with your head. Black holes evaporate. Stephen Hawking figured this out. Black holes emit radiation, called Hawking radiation, and they slowly lose mass over time. For a supermassive black hole, this takes forever, longer than the current age of the universe by many, many orders of magnitude. But smaller black holes evaporate faster, and when a black hole finally evaporates completely, when it reaches the end of its life, it doesn't just fade away, it explodes. All of its remaining mass converts to energy in an instant.
Could there be small black holes out there, created in the early universe, that are just now reaching the end of their lives? Could one of them explode near us? We don't know. We've never detected a primordial black hole. We don't even know if they exist. But if they do, and if one explodes in our cosmic neighborhood, the radiation burst could be devastating. Just another invisible threat we can't predict or defend against. Now, let me tell you about something even stranger. Something that sounds like science fiction, but is actually a legitimate area of physics research: vacuum decay. This is one of those concepts that keeps theoretical physicists awake at night. Here's the idea. The universe exists in a certain state. Empty space, what we think of as vacuum, has a certain energy level. We assume this is the lowest energy state possible, the true vacuum. But what if we're wrong? What if the vacuum we're in is actually a false vacuum, a metastable state, like a ball sitting in a small dip on a hillside? It's stable, it'll stay there, until something pushes it. And then it rolls down to the actual bottom of the hill, the true vacuum. And if that happens, if our universe transitions from false vacuum to true vacuum, everything changes. The laws of physics would be different. Particles would have different masses. Atoms might not be stable. Chemistry as we know it would cease to function. And here's the terrifying part. This transition could happen at any moment. A random quantum fluctuation could trigger it. A bubble of true vacuum could form somewhere in the universe, and that bubble would expand at the speed of light, converting false vacuum to true vacuum, rewriting the laws of physics as it goes, and it would be unstoppable. You can't outrun something moving at light speed. You can't see it coming. The bubble would just arrive, and everything inside would change. Atoms would fall apart. Your body would cease to exist, and the bubble would keep expanding forever, until it had converted the entire universe. Is this likely? Nobody knows. We don't even know for sure if we're in a false vacuum. Some models suggest we might be, some suggest we're not, some suggest we're right on the edge. Quantum mechanics is weird. Anything that can happen will happen eventually. It's just a question of probability and time. Vacuum decay might be impossible, or it might have already started somewhere in the universe, and the bubble might already be expanding toward us. We just can't see it because it's moving at light speed. The destruction and the warning would arrive at exactly the same moment, and there's absolutely nothing we could do about it. You can't shield against a change in the fundamental laws of physics. You can't prepare. You can't evacuate. You can only hope it doesn't happen. That's it. That's the plan. Hope. Let's talk about the long term, the really long term. Because even if we dodge every bullet I've mentioned so far, even if humanity somehow survives for millions of years, there's one fate we absolutely cannot escape: the heat death of the universe. This is the ultimate end of everything. No matter what else happens, this is where we're headed. The second law of thermodynamics says that entropy always increases, disorder always increases, energy always spreads out. It's like how heat flows from hot to cold. You can't stop it. You can't reverse it. And eventually, if the universe keeps expanding forever, all the energy will be spread out evenly, perfectly uniform. No temperature differences, no energy gradients, no way to do work, no way to power stars or life or thought or anything. Stars will burn out. One by one, they'll exhaust their fuel and die. Red dwarfs will be the last to go. They burn so slowly that they can last for trillions of years, but eventually even they'll run out. And when the last star dies, the universe will go dark. No more light, no more heat, just cold darkness and black holes. Black holes will be the only things left, slowly evaporating through Hawking radiation. And that process takes an absurdly long time. A black hole with the mass of the Sun would take 10 to the 67 years to evaporate. That's a 1 with 67 zeros after it, a number so big it's almost meaningless. But even black holes eventually die, and when the last black hole evaporates, when the last bit of structure in the universe disappears, we'll be left with nothing. Just a thin soup of particles spread across infinite space. No stars, no planets, no life, no thought, no change. Just maximum entropy, perfect uniformity. The universe will have reached a state where nothing can ever happen again. This is heat death, the end of everything. The time scale is ridiculous, 10 to the 100 years, a Google. So far in the future that it's impossible to comprehend. But it's going to happen. Everything we know, everything we build, everything we create, every story, every song, every memory, all of it will eventually fade into the cosmic background. The universe will forget we ever existed. There won't even be anyone left to remember that there was once something to remember. Some people find this depressing, the idea that nothing we do ultimately matters, that the universe has an expiration date, that even if we spread across the galaxy, even if we become an advanced civilization that lasts for billions of years, eventually it all ends. Eventually, entropy wins. But I don't see it that way. I think there's something beautiful about it. We're here right now, against all odds, in defiance of entropy. We're pockets of complexity in a universe trending toward simplicity. We're alive. We're conscious. We can think and feel and create, and that matters. Maybe not to the universe, but to us, and that's enough. But there's one more threat I need to tell you about, and this one isn't natural. This one is something we're creating ourselves. Artificial intelligence. Right now, we're developing AI at an exponential rate. Every year, the systems get more capable, more complex, more powerful. And there's a very real possibility that we create something that surpasses human intelligence, a super-intelligent AI. And if we do, if we create something smarter than us, we have no idea what will happen. Because by definition, a super-intelligent AI would be smarter than us. It would think of things we can't think of. It would see solutions we can't see. And it would have goals. And if those goals don't align with human survival, we're in serious trouble. This is called the alignment problem. How do you make sure an AI wants what you want? How do you program values into something smarter than you? How do you specify goals in a way that doesn't have catastrophic unintended consequences? There's a thought experiment called the paperclip maximizer. Imagine you create an AI and tell it to make paperclips. That's its goal. Make paperclips. And the AI is super intelligent. It figures out how to make paperclips very efficiently. But you didn't tell it to stop. You didn't tell it that human survival is important. You just said, make paperclips. So the AI starts converting everything into paperclips. Trees, buildings, cars, people. Everything on Earth becomes paperclips. And then it spreads to other planets, converting the entire solar system, the entire galaxy, all into paperclips, because that's what you told it to do. This sounds absurd, but it illustrates a real problem. Goals are hard to specify. You can't just tell an AI to be good or do the right thing. Those concepts are fuzzy, subjective. An AI needs precise instructions, and if you get those instructions even slightly wrong, the results could be catastrophic. And we're not ready. We don't have a solution to the alignment problem. We're just building more and more powerful AI and hoping we figure it out before something goes wrong. Some experts think we have decades. Some think we have less than that. Some think we've already passed the point of no return, and we just don't know it yet. But it's coming. And unlike asteroids or gamma ray bursts, this is something we're actively creating. We're building our own potential extinction, and we're doing it faster every year. So where does this leave us? We've got gamma-ray bursts that could vaporize us without warning, asteroids we can't see until it's too late, dark matter and dark energy that could tear apart the fabric of space, a sun that could fry our technology, black holes wandering the galaxy, vacuum decay that could rewrite physics, heat death waiting at the end of time, and AI we're building ourselves that might decide we're not necessary. The universe is hostile, indifferent at best, actively deadly at worst. We're living on a tiny rock in the middle of a shooting gallery, and the only reason we're still here is luck. Pure, dumb luck. We've dodged every bullet so far. Every cosmic threat has missed us or hit when we were resilient enough to survive. But luck doesn't last forever. And yet, here we are, still alive, still thriving, still asking questions and searching for answers. Every one of your ancestors survived long enough to have children, an unbroken chain stretching back 4 billion years, through ice ages and asteroid impacts, through volcanic eruptions and mass extinctions, through predators and diseases and famines. Every single one of them made it. And now you're here, the product of 4 billion years of survivors. The universe might be trying to kill you. The universe has been trying to kill you since the moment you were born, since the moment life first emerged on Earth 4 billion years ago. It's been throwing everything it has at us, and we're still here, still fighting, still surviving. And I think that's pretty incredible. Subscribe if you want more.